Hi, in this video let's look at equivalence operator in constraint block. Equivalence operator, this is how it represents, this is what is called as equivalence operator, and is a equivalence operator is a bidirectional. Let's say an example, ran bit a comma b, and constraint written as a is equal to 1, equivalence operator b is equal to 1. Like what does that mean is, the possible values are like if a is 1 then b must be 1, and if b is 1 a then a must be 1. Earlier in implication operator, it's a unidirectional, where if I have implication operator here, when a is 1 then b must be 1. Reverse is not true. When b is 1 a need not be 1 in implication operator. In equivalence operator, when a is 1 b must be 1, when b is 1 a must be 1. This is bidirectional. That's what the bidirectional is. Similarly, this operator is bidirectional, constraint one value which fixes the other value, and similarly if a is 0 then b must be 0. Let's look at an example quickly. Let's run and see the same code what I explained till now. Here random bit a comma b, constraint a is equal to 1, equivalence operator b is equal to 1. In this module, instanced the class, constructed the class, repeated, randomized for 10 times with the display statement. Let's see what all the results look like. A is equal to, a is 1, b is 1, a is 0, b is 0. You see, all are like when a is a and value, a and b has same value, and the same constraint can be written as written like this. Since it is a bit, this if we rewritten like this, it will still work, since it is a bit. If it is not a bit, data type of bit and size of 1. Otherwise this, if I rewrite like this, the same constraint, the previous constraint doesn't look same. Like what I mean is, like this constraint, this can be changed like this, a equals operator b, and this will work only if data type is bit, size of 1. Okay, and let's see the example similarly how. Okay, a is 1, b is 1, a is 0, b is 0, and you see like it will work same, since it is a bit of size 1. If it is more than bit size is not 1, more than 1, then we cannot replace the previous constraint with this. Okay, that is different. Here next, and okay, let's change the constraint little bit. The same constraint, random bit a comma b, and let's constrain add another one more constraint where a is equal to 1. What I'm doing here is I'm constraining in two lines. Like one is a equivalence operator b, and one more constraint is a is equal to 1. And the possible value is, like, now there is no possibility of a is 0, a can always be 1. So because of equivalence operator, b will also be 1. This is always, this is the only possible value. Okay, let's add this in the code and see how it works. A equal to 1. Okay, let me run and see. We will get only one value, like a is equal to only this one. Yeah, a is equal to 1 and b is equal to 1 always. Like there is no other possibility. Okay, let's look at the other example where for the same constraint I have added one more line, like earlier a equivalence operator b, and a is equal to 1 and b is equal to 0. Let's see. Actually, expectation is constraint solver should fail. I am going to add one more constraint, b is equal to 0. Let's add that and see. Now we should get a constraint solver error. here there is some randomization failed, test bench 17, this line randomization failed, the condition is called cannot be, you see here randomization failed, line number test bench dot sv line number 17, which is this line, randomization failed, the condition randomize call cannot be satisfied, and 17 after reduction to b to 0, reduction to b to 1. Okay, this is all like basically the constraint solver. This is actually in general in other simulators you will might see that the test won't move forward. Actually, it will just simply fail at this point. Okay, here you might be getting 0 because the default value of data type bit is 0. That's the reason it is printing 0. But basically in other simulator you will see that nothing will displace because randomize fails, it simply exit. Okay.